So in this video, I want to teach you how to work with actual rational expressions. And really what you're doing is you're adding fractions. We're going to add rational polynomials, all right? So in order to add any fraction, the first thing you must have a common denominator. So a quick example, let's say I wanted to add 2/3 plus 3/4. Remember that when we add these up, in order to add them, these have to be the exact same denominators. So we're going to look for what we call our least common multiple, or the LCM. And we want to get these to the least common multiple. So the least common multiple between 3 and 4 is going to be, well, you can do it like this. Literally, you're going to go 3, 6, 9, 12, 15, 18. You would go 4. 4 would be 4, 8, 12, 16, 20. These are the least, so you want to get them both to 12. So to get those to 12, you would multiply this side over here by the number 4, because you're multiplying by what's going to make the denominator 12. So that's 4. To this other one, and then what you're really doing is you're multiplying by a special form of 1. If you multiply the bottom by 4, I also multiply the top by 4. So really what 4 over 4 is 1. So you're not changing the problem at all. Same thing over here. Multiply this one by, well, I need to multiply this by a 3, so I'm going to multiply the top by a 3. And so now I can convert those to the same denominator, and I get 8/12 plus 9/12. And now I can add them. And remember, when I add them, I just add the tops. The bottom stays at 12. 8 plus 9 is 17. So that process works for just like that for polynomials as well. So in a polynomial, the first thing you're going to do is we're going to first factor to look for the LCM. Second step you're going to do is you're going to find the LCM. Third step, multiply the LCM by the numerator and denominator. And then the last thing you're going to do is you're going to, at the very end, you want to simplify the expression by reducing. So let's practice this process. So we have 2y over 5 minus 3y over 15. The only thing I care about is making sure that I have the same denominator. And so I'm going to look for the LCM between, first thing I'm going to do is I can factor the bottom if I can. I can't factor here. So I'm going to try to get them both to the same denominator, the smallest LCM they have, and their LCM is equal to 15. So this one right here, to get it to a 15, I have to multiply it by 3, but I multiply top and bottom by 3. So 3 times 2y is 6y, 3 times 5 is 15, minus, this is already at 15, so I'm really just going to multiply it by 1 and leave it alone. So that's 3y over 15. I subtract this now. 6y minus 3y is 3y, just the tops. The bottom stays at 15. If I can reduce it, I will. And I can't reduce this because 3 and 15 both have a common factor of 3 in them. So literally I'm dividing the top by 3. There I get a y. Divide the bottom by 3. I get a 5. So let's reduce this to. So if you look at 2, first step, we're always going to try to factor first. So notice here I can factor x squared minus 4 into x minus 2 and x plus 2. The LCM is going to be the term when you look at a polynomial like this that is missing, or that both have, and then you need to give it the term that's missing. So in this particular case, if you notice the bottom of this fraction, there's already x plus 2. So they both have to have the x plus 2 term. But then this one is missing the x minus 2 term. So I also need to give it the x minus 2 term. So I'm going to multiply by what's missing in the denominator on both sides. If you notice here, I need to have an LCM of x plus 2, x minus 2. This side already has that x minus 2, x plus 2. So I won't touch it. I'll just multiply it by 1. And I get 6x over, I'm going to write it in factored form, x minus 2, x plus 2. Now, this side over here is missing the x minus 2. So I'm going to multiply top and bottom by x minus 2. So when I do 3 times this top, I get this. And it's a negative 3, by the way. So minus 3x plus 6, because it changes your signs, over the LCM, which is x minus 2, x plus 2. And remember, when we add fractions and when we add these common expressions, the bottom will not change. So the bottom is going to be the LCM x minus 2, x plus 2. The top will combine like terms. So I have a 6x minus a 3x. That is 3x. And I have a, technically it should be a positive, so I messed that up. So it's 6x plus 3x. I messed that up because I already distributed the negative out. So 6x plus 3x is 9x plus 6. And again, if you can factor, the top actually has a 3 in common, but you can't do anything with it, so we can leave it like this. On the next one, notice I have 1 plus x over x plus 1. So this has a denominator of x plus 1 already. We can't factor anything, so I'm going to look for the LCM. The LCM is going to be this term right here, which is x plus 1. Both terms need it. This term does not have it, so I'll multiply top and bottom by x plus 1. So really and truthfully, what you're doing is you're multiplying denominators by what's missing. That's a good way to put it. You're going to multiply denominators by what's missing. So if this has an x plus 1, this doesn't have the x plus 1, I need to multiply the entire problem by the x plus 1. So the top is just 1 times x is x, and 1 times 1 is 1, so that's x plus 1 over the denominator of x plus 1 plus, well, this one already has everything, so I'll just multiply by 1, x over x plus 1. The bottoms do not change, so that'll be x plus 1. Top is 2x, x plus 1. Can't be factored, so this is in the reduced form. This last one, notice if we can factor, we're going to factor first. Let's factor here, because that factors into x minus 1, x plus 1, difference of 2 squares. And now from this, let's look at the terms that we have. This term has an x. This term has x minus 1, x plus 1. This term has x plus 1. So my LCM is going to be all those terms I need to pick up, which are going to be x from the first term, x minus 1, x plus 1 from the second term, and this term already has the x plus 1, so we'll leave it like that. So we're going to multiply by what's missing. In this first term right here, we're missing the x minus 1 and x plus 1 that already has the x. So I'll multiply this by x minus 1, x plus 1. And when I do that, I'll get, well, this, just distributing it out right here, it's going to distribute to x squared minus 1. We've already seen that down here from the factored form. And then I have that 3 sitting in the front of everything over x minus 1, x plus 1, minus here. Sorry, and I also have an x too, that x term. Here, this one is just missing the x term. So that'll be negative 2x squared over x times x minus 1, x plus 1. And then that last one will be, I'm missing the x minus 1 and an x. So this last one is missing x and x minus 1, which will be plus 5 times x squared minus x. When I distribute it out like this. And this bottom will be just x times x minus 1, x plus 1. So when I do this, I get, cleaning things up now at the top here, 3x squared minus 3 minus 2x squared plus 5x squared minus 5, all over the common denominator of x times x minus 1, x plus 1. If I clean this up even further, 3x squared negative 2x squared, that's a positive x squared, plus this is 6x squared. So that's 6x squared, and I clean up all my x squareds. Then I have a, sorry, that was a 5x. Then I have a minus 5x. And then I also have a minus 3. Now, all of this over x times x minus 1, x plus 1. So this is the final answer here.